Welcome to Yandra Technologies. In this present video, we are going to learn how to do the traffic signal simulation using this kit. So we have the serial port for programming as well as powering the circuit, and we are inserting this cable here and take the other end of this cable and connect it to the PC. Once if you connect it, you get the device powered on, and what you have to do is just go to your system and click on the Keel Microvision. We'll provide you this, and here you need to create a new project. If you are starting it in the beginning, create new Microvision project. Of course, I have a different project. I'll call this as PRJ1. I'm giving a name PRJ1 for this, and I click on the save. Then it asks me which processor do I want. So I have to choose ATML, and under ATML scroll down until you get 89S52. 89S52, you can see this, and click on OK. It asks you whether you want to add the standard startup code. You say no, it's not required. So this will create a project, and here we are going to add some files to the source group. So double click on this, it will give a pop-up, and here I have already tested some programs. First of all, we are going to learn how to do the traffic signal simulation, and make sure you click on ASM source files. If you have C type files, then you click on C, but we are now teaching in assembly language coding, so I am choosing ASM. So here I have LCD, serial communication, traffic signal, etc. Now I am choosing the traffic signal. I'll add the code and then close. Once after I add, I'll get this file appeared here, traffic signal.asm. Let me double click, it will open the window. So please try to understand, here we have the port pins connected to different LEDs according to this description. North side LEDs. North side red is P3.2 port 3.2, yellow is port 3.3, green is port 3.4, and similarly west side red, yellow, green, to different pins, 12 different pins we have assigned to this. So all these LEDs are connected to these pins first. So ORG0H, beginning of the program, loop. So this is going to loop forever. So we have written subroutines. So first subroutine is ACALL EASTG. So this EASTG actually refers to east side green. So there is a function at the bottom that is east side green, and similarly we have delay 1, which gives some waiting time delay using resistors, and FLKE, FLKE means east side orange LED will be flickering. So the traffic signal likes the following way. First it gives green to east side, and remaining 3 sides it will be red. It waits for some time, and while rotating the signal from east to the next one will be north side. So it will come to the north. So before jumping onto the north side, it gives orange yellow warning LED. So that we are doing with flickering. So that function is ACALL flicker east side. And then next one ACALL NORTHG. So north side green and delay, wait for some time, and FLKN. So it is going to flicker the north side orange LED. So similarly then it goes to west, wait and flicker west side, and then go to south, wait and flicker the south side, and then it repeats itself as a loop. Let us see what happens when we call this EASTG. So there is a EASTG function here, ACALL CLEARPORT. So CLEARPORT is another subroutine which says all the ports are cleared, that is all the port pins are made 0. So you can go down, if you scroll it, you see CLEARPORT function. So move P0, 0, P1, 0, P2, 0, P3, 0. So all the 4 ports of this 8051 pins are cleared. So they will be low, no voltage will be given there, 0 volts will be given. So after clearing the ports, then it comes back to the next one. So we have the EASTG. So SETB P0.4, SETB P3 3.2, 1.0, 3.5. You can easily understand that this is going to set the red color LEDs of all the three sides except east side, and on east side only green LED is on, red LED is off. So remaining three are the red LEDs. And similarly, if you go to the other ones like WESTG, NORTHG or SOUTHG, you will find the same thing. First of all, it makes sure that all the LEDs are cleared, and then it is going to set only that particular side's green pin with the remaining all the three sides red LEDs on. So west, east, north, and same thing is applicable to SOUTHG also. Here also we are going to set the pins, nothing is going to flicker. So let's come back to this main loop. So in the main loop, first east is there, and then delay function is there. What is delay 1? Let us see here. So delay 1 is a register delay function. You can see here this register delay 1, you can see move R4 comma 20. So we are taking the register for a value of 20 decimal, and then we are calling the delay function, and then it is going back. So about 20 times this so-called delay function will be called. So you can see here the delay function is you can see it's 255 into 255 times it is going to run there, and then it is going to jump back to these loops, and finally it is going to come out. So this is the way the delay function is going to work, and then finally it returns back. So when you call the delay 20 times, that is going to be relatively longer delay. So this delay 1 is used for giving clearance to one side, that is the duration for the green light on a specific side is decided by the delay 1. And then you have this flicker, FLKE. Same thing is applicable to north, west, south also. We'll go with first east, FLK east. You can see here FLK east. So ACALL EASTG. So once again we are calling back the function. It's not necessary, but we don't know whether it has come from the east state or not. So to make sure that east side is green given, so we are giving this function, so it makes sure that green side LED is cleared. Green side is east side is given with green signal, and then we are going to wait for some time. So we have another register with which we are loading with the 6, and then CPL P0.3. So this is the orange LED on east side. So we are going to CPL means complement. So before we give red signal, we are going to flicker the yellow light for about 6 times, on off, on off, on off, and then it is going to come out. So you can see here, so this loop complementation happens for 6 times and then comes out, and finally it is going to clear this orange LED, and it is going to set the red LED on that side, and it is also going to turn off the green LED and returns back. So this is the way each side is being flickered. After the flicker, you will go to the next stage, and there also you will be flickering the corresponding LED on that particular side. So this is the code, and we will try to upload it. Before you upload it, please make sure to make some settings. So there is a target options folder. Click on here. It is by default 33, but you have to set it for 11. I am typing here 11.0592. So we are using 11.0592 megahertz crystal. So we have to change this number. That is the first thing. And the second one is output. By default, create hex file is not there. So we have to check this box and then click OK. Remember 2 things. First thing, you have to change the frequency, that is 11.0592, and output you have to create hex file. OK. Now when everything is done, you just go to this particular icon, rebuild. So if you click on the rebuild, it is going to build all the files. If at all your coding is right, it gives you 0 errors and mostly 0 warnings, but error should be 0. If at all no errors, your project is done, and you will have a hex file created with the name prj1.hex. Right, successfully it is over. Now I'll give you another one. This is the 8051 ISP programmer. It is available in the software provided to you, and here you make sure that first of all you click on the disconnect, and then connect button will come. It gets highlighted, and make sure that your port is correctly connected. Here my serial port, that is the programmer's port, is COM5 because that is the only port connected. COM1 is the DB9 port which I am not using. So COM5 I am selecting. It may be different in your case. You may get COM9, COM10 or COM7, whatever number you get, you please try to select that port and then click on connect. Now you need to open the hex file. First of all, you have to make sure that see I am already in the same project, PRJ1. So with the same project title I will have hex file built, prj1.hex. So let me select and click on open. When I open this, the file will be loaded, and then I can click this upload hex. See, the process is now happening here. It is showing the bar. Once if the process is over, yeah, now you can see it is east side over, now north side is given. Now let's see flickering and then red. West side flickering red, south side flickering and then red, east side flickering and then red, like that. So we have given a small delay because we want to display it and we don't want to put it on the real road. So to make the entire thing happen fastly, we have given small delay. It's up to you to change the delay. If at all you change the delay function, you give more delay, obviously you are going to get more time between these things. Let me show you that also. I'll change this number in the delay function. I have delay 1 with 20. Now I'll change this to, let us say, some 70, and once again I'll click on save button, build targets. If I didn't make any mistake, yeah, it is error free, no errors shown. Now I'm ready to upload. Once again I select the programmer. So once again I have to open the hex. See, as long as the board is connected, you don't have to disconnect it. So you just keep it connected and open the hex. Once again you have to relocate the file because the file has been updated. So every time you have to make sure that you reload that freshly and then upload the hex. So it is going to upload it, and while uploading, see, this gets frozen, and once if it is over, yeah, now it's over, you see you get a little more delay. So it is now in green only, it's taking long time. Yeah, now it is flickering, changed. So it takes about 3 times the previous one. So it's taking about 5 to 10 seconds delay, about 10 seconds. Yeah, now it is flickering and then clear. Now you can see once again this is going to flicker west side, this, and same thing happens. So in this way you can change the delays. This is totally plug and play board. You don't have to remove the chip or connect any extra peripherals. It is total wiring free. Just you can plug and play. Thank you.